Hi, Algebra. Today we're going to learn how to factor a trinomial. This is a 2-day lesson. So you can put the date of 3/24 at the top of your notes, and then we'll pick up again tomorrow with some more examples. This is the note packet that you're going to need today to go through the notes, and again tomorrow. Remember, you can pause the video at any time if you need to stop and catch up on notes, or if you want to try examples on your own. Let's review. This is a product. They're asking me to multiply two binomials. In class, we use the distributive property, and we're going to start by distributing x squared to x, which is x to the third, and then x squared to -4, which is -4x squared. Then we're going to return and distribute the 2 to x, and then distribute to -4. So what you're seeing is I get 4 separate terms. If any of the terms can be combined, we will combine them. And then we want our answer to be in standard form. Remember, standard form is when you start with the greatest exponent, and then you slowly decrease until you have only the constant. When you make the polynomials a little bit larger, this is a binomial and a trinomial. 2 times 3, I should have 6 terms when I'm done distributing. So I'm going to start with the 2x, and I'm going to distribute that first. And I get the first 3 terms of 6x cubed minus 10x squared plus 8x. Then I'm going to return and distribute the -3. And I should have 3 more terms, -9x squared plus 15x minus 12. In this particular problem, there are like terms. I'm going to start, though, and put it in standard form with 6x to the third. And then I'm going to combine my x squareds, my x to the first, and then lastly my constant. So your final answer is in standard form, just like that. What we're going to do today is called factoring. We're going to take the polynomial that they provide us, and we're going to break it into at least 2 parts. As we get better at this, there could be more parts, and those are called factors. And typically they're prime factors, and they can't be broken apart any further. When we break the polynomial apart, what we're doing is the opposite of distributing. So distributing and multiplying your polynomials and then factoring your polynomials are opposite processes. So we're going to take a trinomial, and then we're going to learn how to separate it so we get 2 quantities like this one. And there is a little bit of a trick to it. So again, we want our trinomial to be in standard form. So we want the greatest power, and then the next greatest power, and then finally the constant. A, B, and C represent coefficients. So here's a trinomial where the coefficients are actually filled in. When we talk about A, the value is 3, B has a value of 4, and C has a value of 5. When you separate it like this, we do not include the x or the x squared. It's simply the coefficient. So the method of separating that we're going to try is called the product sum method. What we'll do is we'll separate into 2 factors. We're going to find the value of C, and we're going to list all the factors that would create it. That's a product. But the set of factors you choose that create C must also add up to the value of B, which is a sum. So this is why they call it the product sum method. In order for this method to work, the value of A must be 1. If it's anything other than 1, we'll have to try a different method, and that's something we'll learn later on. We're going to use this first example and walk through the procedure. So in this first example, I can see that the value of A is 1, so the product sum method should work. The value of B is 10, and the value of C is 24. One of the things you want to pay attention to are the signs of B and C. So if they're positive, likely both of your factors are positive. But if one's positive and one's negative, we might have to look at a combination of factors that contain both a positive and a negative. So here's the procedure. We want to look at the value of C, and in this case it's 24, and we want to make a list of factors that will multiply to 24. And again, the sign will be important. So since 24 is positive and 10 is positive, both of the factors that I want to pick have to be positive. When I list my factors, I start at the beginning with 1, and I go through them very thoroughly to 2, to 3, and so on. So my first set of factors will be 1 and 24. If you look at those, they do not add up to 10. So the next set of factors is 2 and 12. They do not add up to 10. 3 and 8 do not add up to 10. And 4 and 6. That set does add up to 10. But I'm going to make a list of all the possibilities to create 24. Step 2 is to select the 2 that do add up to B. So we know that that is 4 and 6. I've highlighted them in red. The final step is to actually break into 2 binomials. Now, the 4 and the 6 are part of that answer, but what we have to also look at is x squared. I need to separate that into 2 factors. Well, the only way to do that is to have x times x. So in step 3, when I write my answer as a product of 2 binomials, the x's from x squared will start us in both of our binomials, and then the positive 4 and the positive 6 will be the second quantity in those groupings. Now, you don't have to list positive 4 first. You could just as easily list positive 6 first and then positive 4. When you distribute, you'll see that you should get back the original trinomial of x squared plus 10x plus 24. So problems like this have a built-in check, and you should just go through and make sure that your combination works. All right, so let's try one. We want to list all the factors that multiply to 12. So starting at the beginning, I've got 3 sets, and now I want to select the set that will add up to positive 8. So when you check this out, we can see that positive 2 and positive 6 will be the correct solution. So when I set up my 2 binomials, they'll both start with t, and then we'll use plus 2 and plus 6. For our next example, we want the factors to multiply to positive 21. However, the value of b is negative. So in a case like this, my factors have to both be negative. So I'm not even going to list the positive values. So there are my options for factors. And we want to select the set that adds up to negative 10. And there it is. And then when I break apart my quantities, both of my groupings will start with x. So it'll be x minus 3 and x minus 7. In example number 3, we can see that the value of c is negative 18. When this value is negative, that tells me that there's 1 positive factor and 1 negative factor. So here are the possibilities for negative 18. What I want is a grouping that will add up to positive 3. And it looks like negative 3 and positive 6 will add up to positive 3. If you decided when you listed your factors to put the negative on the 18, the 9, and the 6, it's okay. When you add them up, you'll see that you would have gotten negative 3, and that just tells me that the signs are in the opposite setup. And you can go ahead and fix that. So when I'm done, d squared separates into d times d, and I'll use my negative 3 and my positive 6 to complete my factors. For number 4, again, c is negative. That tells me I have 1 positive and 1 negative factor. So I'm going to make a list. We want this factor group that adds up to negative 1. So positive 3 and negative 4 will do that. And when we write our 2 quantities, both of them will start with d. We're splitting apart d squared. So we'll have d plus 3 and d minus 4. Example number 5 looks a little bit different. Instead of seeing a trinomial, I'm only seeing a binomial. You can see that there's a term missing in between. I started with the second power, but then typically I should have a p to the first power. Well, what happened is that term was removed. So what I can do is rewrite it to include it. When a term is missing, you can reinsert it with a coefficient of 0. So what I'm looking for in this factor grouping are factors that will multiply to -9. So if I list those, I have two options, but I want the set that adds up to 0 in the middle. So for me, that's going to be +3 and -3. The rest of the process is the same. I have p squared starting my binomial. So when I break it into factors, both of the quantities will start with p, and we'll have +3 and -3. And again, it doesn't matter if the -3 comes first and then the +3. Remember, you can pause the video if you want to try some of the upcoming examples on your own. As the value of c gets larger, that means we'll have more factors to list. Once you get good at this process, we won't have to list factors anymore. You'll probably be able to just create that in your mind and list it. But for 36, it's positive, but I do need to add up to a -13. So this tells me that my factors are both going to be negative. And here's a complete list of possibilities for +36 that are negative. We want to select the grouping that adds up to -13. And right here, -4 and -9 will do that. And then again, we're going to split n squared, so it'll be n minus 4 and n minus 9. Let's do two more examples for today. Number 7, we're listing factors that multiply to -12, have a short list, and then adds up to +4. -2 and +6, and then our quantities will be n minus 2 and n plus 6. And finally, number 8, we're looking for factors that will multiply and create -9. That tells me I have one factor of each positive and negative. And the list is pretty short here. The pair that adds up to -8. And then finish it off with splitting apart our n squared. We have n minus 9 and n plus 1. This is homework number 94. You should find this in your packet. Make sure you grab the one that starts with number 1 being p squared plus 12p plus 20. It's the shorter of the two assignments. It's just a front and a back. Feel free to make the list of factors down the side, and then you can write your binomial answers right in there. If while you're going through this homework you have any trouble, don't be afraid to call me at home. I'm available between 8 and 3. You can call me or text me on my cell phone, or you can just shoot me an email at school, and I'll be checking that throughout the day. Have a great day.